Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this video is on the this video is part of the series of videos titled Concepts to Remember, where I discuss about the key concepts, formulas, topic wise for a particular chapter. And this video is on the chapter Properties of Triangle, and this is topic B, where I will discuss the key concepts and the formulas and some typical critical thinking pattern of question on the subtopics types of triangles and angle sum property. In the previous video, I discussed about the topic A, which was the basics of a triangle. On the same chapter, properties of triangle. If you have missed that video, I highly suggest that you also watch that video. This video is also in this series of videos. I also attach a few sample problems based on the key concepts that I will discuss in a particular topic. So this video is part of the playlist CBSE Mathematics for class 7, following the textbook of author R.S. Agarwal. If you are new to my channel, or if you are not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I highly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with this video. Okay. So I have my rough notes and the key concepts that I will discuss in this topic B on the chapter Properties of Triangles, that will cover two topics, that is types of triangles and angle sum property. So as you know that in this series of videos I will only mention the key concepts. I will not discuss much. I have lots of points to cover. As you can see, there are almost 15 points that I will talk about and do a little bit of discussion wherever necessary. And I will attach the link. I will mention the link of the PDF of the sample problems in the description below. You can check that out. And if you need the solution for a solution video for the sample problems, then please do let me know in the comment section. Now I forgot to mention that these series of videos that I am making, which is under the title of Concepts to Remember, this is highly inspired from the section Things to Remember that you will see in most standard Indian author textbooks. In some author textbooks it is under the section Things to Remember. In some other books it is Points to Remember. In some other books it is what we have learned or what we have discussed, and in some other books it might be summary. Anyway, so the concepts to remember, this series of videos is highly inspired from that section of the most standard books. Okay, now let's discuss about the key concepts of the subtopics types of triangles and angle sum property. Okay, so point number 1, all angles of an equilateral triangle measure 60 degree. This is very basic. You must already be familiar with this. So in an equilateral triangle, all the angles are same and they are equal to 60 degree. Point number 2, in a right angle triangle, two other angles are complementary. In a right angle triangle, two other angles are complementary because this actually depends on the point number 5, which says that in any triangle ABC, let's talk about this. In any triangle ABC, we have the sum of the angles is always equal to 180 degree. So in a triangle ABC, we will have angle A plus angle B plus angle C equals to 180 degree. So this is known as the angle sum property. So based on this property, a lot of other concepts is established or deduced. So the fact that in a right angle triangle, let's do the little bit of discussion point wise. In a right angle triangle, two other angles are complementary. Why? Let's say the angle is equal to 90 degree. In a triangle ABC, let's say angle A equals to 90 degree. Now Now we must have the sum of all the angles should be equal to 180 degree. So we must have angle A, angle B plus angle C equals to 180 degree. So this implies A is 90 degree. We have assumed that angle A in the triangle ABC is 90 degree. So we have 90 plus angle B equals 180 degree. So this implies angle B plus angle C equals 90 degree. So we know that if the sum of any two angles is 90 degree, they are said to be complementary to each other. So that is the reason in a right angle triangle, means one angle is 90 degree. So the sum of the other two angles, we can see that it will be their sum will be 90 degree, and hence the other two angles are complementary. Okay. Point number 3, the angles opposite to the equal sides of an isosceles triangle are also equal. So whenever you see in a diagram, you have, let's say, this is a triangle. My figure is not perfect, it is just an approximate figure I am drawing. Let's say it is given a triangle ABC, and it is said that it is an isosceles triangle, so two sides must be equal. Let's say the side, we have, it is given that AB equals to BC. So AB bar means the length of the side AB, and BC bar means the length of the side BC. So in the figure, diagrammatically it is shown by two small parallel lines on the equal sides. So if you see a figure like this, you immediately know that the length of the side AB is equal to the length of the side BC. Now if this is the case, then it is saying that the angles opposite to the sides will also be equal. The angle opposite to side AB is C, and the angle opposite to side BC is A. So this will imply that angle A is equal to angle C. This is a very important property. Always remember that the angles opposite to the equal sides in a triangle are equal. Okay. Point number 4, all angles in a scalene triangle are unequal. Now in a scalene triangle, you know that a scalene triangle is a triangle where all the length of all the sides are of unequal size, are different. So in that case, the angles are also different. Now I don't know the proof, but please remember this as a fact or as a concept, that in a scalene triangle all the angles are also different. Okay. Point number 5 we have already discussed. It is the angle sum property. Point number 6, a triangle cannot have two right angles. Okay. Point number 6, I mean, these are very basic fundamental concepts, you might already be familiar, but let's go through them anyway. So a triangle cannot have two right angles. So let's say angle A equals to, in a triangle ABC, let's say angle A equals to angle B equals to 90 degree. Now we know that the angle sum property will always hold. It will always hold in any triangle. So we must have angle A plus angle B plus angle C equals to 180 degree. Now this will imply that angle A, angle A is, we have assumed to be angle A, and angle B we have assumed to be 90 degree. So 90 degree plus 90 degree plus angle C is equal to 180 degree. This implies, if you simplify, you will see that angle C is coming to be 0, not possible, because we have already discussed in the topic A video that in a triangle the length of all sides are always greater than 0, and also the measure of all angles, every angle in a triangle is also greater than 0. Hence we can say that two angles in a triangle cannot be 90 degree. Okay. Point number 7, a triangle cannot have two obtuse angles. The reason, logic is same. Let's say, so we have, so let's say angle A, obtuse angle means an angle which is, let's say A and B are the obtuse angle. So we have, let's say A and B are obtuse. Let's say it is saying that a triangle cannot have two obtuse angles. Let's verify that. So let's say if angle A and angle B are obtuse, this will imply what is an obtuse angle? An obtuse angle is an angle which lies which is greater than 90 degree and less than 180 degree. So we have this. We have this inequality, or the range of values, the range of B, angle A and B will be like this. So both angle A and B are greater than 90 degree and less than 180 degree. Now consider what happens to angle A plus angle B. Angle A plus angle B, since angle A is greater than angle B, now this actually implies that angle B is greater than 90 degree. This relation also implies that angle A is greater than 90 degree. Now, so we are having both angle A and angle B greater than 90 degree. So angle A plus angle B will obviously be greater than 90 degree plus 90 degree. This implies that angle A plus angle B is coming to be greater than 180 degree. Not possible, because the sum of the three angles of any triangle is always equal to 180 degree. So this is the reason that two angles in a triangle cannot be obtuse. Okay. Point number 8, a triangle cannot have all angles greater than 60 degree. And point number 9, a triangle cannot have all angles less than 60 degree. The concept, the logic used to verify this is the same, that the sum of angles of any triangle is equal to 180 degree. Now, if let's say a triangle cannot have all angles greater than 60 degree. Now, if that is so, let's say all the angles in a triangle ABC, all angles ABC are greater than. So let's say we have this. All angles ABC are greater than 60 degree. 60 degree. Now, this will imply that angle A plus angle B plus angle C will be greater than 60 plus 60 plus 60 degree. This is equal to 180 degree. So not possible. The sum of angles, three angles of a triangle is always equal to 180 degree, and we are getting that the sum of the angles is becoming greater than 180 degree. Not possible. So all the three angles of a triangle cannot be greater than 60 degree. Similarly, the same logic holds if we have A less than 60 degree, angle B is also less than 60 degree, and angle C is also less than 60 degree. This will imply that angle A plus angle B plus angle C will be less than 60 plus 60 plus 60. So this is 180. So the sum of the angles of a triangle cannot be less than 180 degree. It is always equal to 180 degree. So this is the reason also why all the angles of a triangle cannot be less than 60 degree. Okay, point number 10, in an isosceles right triangle, the two acute angles are equal and measure 45 each. So in an isosceles right triangle, meaning the triangle is right angled, that is one angle is 90 degree, and isosceles means its two sides are same. So now why is it that in an isosceles right angle the two acute angles are equal and measure 45 degree each? Now we have already seen that in a triangle there cannot be 290 degree. So in an isosceles right triangle, so we have this kind of triangle. Let's say A, B, C. So this is, let's say this is 90 degree. Let's say angle B equals to 90 degree, and obviously now since we cannot have another 90 degree, in a triangle, so definitely the two, now since ABC is a isosceles triangle, two sides will be equal. That means its two opposite angles are equal. So in this triangle, isosceles right angle triangle, two angles will be same, and those two angles same, it cannot be 90 degree. It cannot be 90 degree. So definitely so we have angle A plus angle C is equal to angle A and angle C will be equal to 180 degree minus angle B. Why? Because we know that angle A plus angle B plus angle C is 180 degree. So angle A plus angle C will be 180 degree minus B minus angle B, and we know angle B we are assumed to be 90 degree. So this is coming to be 90 degree. Now, and hence, and since the angle A and C will be also equal, meaning that in this scenario, if angle B is the 90 degree, then definitely it has to be the case that AB is equal to BC. These two sames, this implies that since the two sides are equal, it is given that it is an isosceles right triangle, and if we assume that the isosceles right triangle is a right angled at B, that is B is 90 degree, then it has to be the case that AB is equal to it cannot have another 90 degree. So definitely the other two acute angles, that is angle A and C, must be equal, and their sum is equal to 90 degree. Now also, so the other two angles must be equal, that is angle A must be equal to angle C. Angle A should be equal to angle C. Now these two fact, angle A is equal to angle C and angle A plus angle C is 90 degree, these two fact will imply that if you solve, this will imply that angle A is equal to angle C is equal to 90 degree by 2, that is 45 degree. So this is what the point is saying, that in an isosceles right angle triangle, the two acute angles are equal and they measure 45 degree each. Okay. Point number 11, it says that, so we have over here a quadrilateral. A quadrilateral is a polygon with four sides. So you can see in this figure, PQRS is a quadrilateral and it has four sides. And any polygon also has some corner angles. As you can see in the figure, angle P, Q, R and S are the angles of the quadrilateral PQRS. It is saying that sum of corner angles of a quadrilateral PQRS is 360 degree. So the sum of corner angles of any quadrilateral is always equal to 360 degree. Now the way it is verified, it is proved, or it is obtained, the result is obtained is that, so you have this P, Q, R and S, we have this quadrilateral. It could be of any other shape, but a quadrilateral has four sides. Now the angle YP, so this and this, their sum is equal to, always in any quadrilateral is always 360 degree. Why is it so? I'm just giving you a very brief and short argument. So if you connect the diagonal PR, you will get two triangles, this one and this one. Now for in triangle PRS, you will have angle S plus angle RPS plus angle PRS equal to 180 degree, because the sum of three angles of any triangle is 180 degree. And also in triangle PQR, you will get angle Q plus angle RPQ plus angle PRQ is equal to 180 degree, because the sum of three angles in the triangle PQR will be 180 degree. Now, if you got this equation, if you got this equation, if you add 1 and 2, these two equation, you will get that so you will get angle S plus angle Q plus angle RPS, angle RPS. Let's combine the angles RPS and PRQ, and we are left with the angles PRS and angle what is this, RPQ. This we got as on the right hand side we will get 180 plus 180, that is 360 degree. Now this implies, if you simplify the left hand side, this is angle S plus this is angle Q plus angle RPS and plus angle PRQ. RPS and PRQ, you will see this is angle P. Similarly, this is angle R. So we got all the angles of the quadrilateral equal to 360 degree. Okay. Point number 12 says that, so you see it's a star, the figure is a star and it is obtained by two triangles, and all the corners of the star, you can see the corners of the star are A, B, C, D, E, F. They are the vertices of the two triangles ACE and BDF. So the point, the concept is that the sum of all the corner angles of a star, I mean a star which is obtained in a star having this kind of figure obtained from two triangles, the sum of the corner angles is equal to 360 degree. The reason is same, you have two triangles, and if you add the corners of all the stars, you are basically adding the angles of two triangles. And since one triangle, sum of the angles of our inner triangle is 180 degree, so we will have 180 plus 180 equals to 360 degree. So the sum of all corner angles of a star is 360 degree. Point number 13 says sum of all corner angles of a n-sided polygon is n minus 2 into 180 degree. So what is an n-sided polygon? So you have the quadrilateral is a four-sided polygon. So let's 13. So what is a five-sided polygon? A five-sided polygon may look like one side, two side, third side, fourth side and fifth side. So we can have P, Q, R, S, T. So we have how many angles? 5 angles. So this is a five-sided polygon. Similarly, you can have n number of n-sided polygons, 6-sided polygons, 7-sided polygons, whatever, 10-sided polygons. So for an n-sided polygon, the sum of these angles, these angles P, Q, R, S, T, all these angles, the sum will be equal to n minus 2 multiplied by 180 degree. So for a five-sided polygon, sum of angles will be equal to 5 minus 2 multiplied by 180 degree. So this is 3 into 180 degree, this is 540 degree. So the sum of all the angles in a five-sided polygon is 540 degree. Okay. Concept 14 is saying that in a triangle ABC, if the ratio of three angles is given to be, let's say in a triangle the ratio of the angles are given. So let's say if in a triangle ABC, if the ratio is given as angle A is to angle B is to angle C is equal to X is to Y is to Z. So and these X, Y, Z are some numbers. It could be fraction, it could be integers, whole numbers, whatever. Then how do you find each individual angles of the triangle, that is angle A, angle B and angle C? So I've written down the formula. This is basically the concept used is from the ratio and proportion. So you know that since in a triangle we will have angle A plus angle B plus angle C is equal to 180 degree, and if it is given that angle A is to angle B is to angle C, let's say I'm taking an example, let's say it is given 2 is to 3 is to 4, let's say it is given like this, then angle A will be equal to the term in the ratio corresponding to angle A, that is 2 divided by all the terms, addition of all the terms, that is 2 plus 5, 3 plus 4, that is 9, 2 by 9 multiplied by 180 degree. So this will be angle A. Similarly, angle B in this example will be 3 by 9 multiplied by 180 degree. So you see the formula is angle A is x divided by x plus y plus z, where is x is the term in the ratio corresponding to angle A. Similarly, you will have for angle B is equal to y plus y divided by x plus y plus z multiplied by 180 degree. Similarly, you will have the C formula. Now, one thing to note over here is that if the ratio xyz is given to be 1:1:1, I mean whatever this ratio xyz is, if you simplify it in the simplest form, so that all the now this xyz could also be like fractions. It could also be like half by 3 by 2, 4, whatever. You first need to convert this given ratio to a form where all the terms are integers. Then in that form, if you see that all the terms are 1, then it will obviously mean that the triangle is an equilateral triangle. That is, all the sides are of same size, same length. So it is an equilateral triangle. And if you see in the simplified ratio, that is whatever the ratio is given, x is to y is to z, you convert it to a ratio where all the terms of the ratio are integers, and in the simplest form, if you see that the sum of two terms is coming to equal to the third term, then it will be a right angled triangle. So in a triangle ABC, if in the given ratio of the angles, if you see if they are already in the simplest form and the terms of the ratio are integers, and if you see that the two terms are adding up to the third term, then it will obviously mean that the triangle is a right angled triangle. Now, if you want to see why is that, let me try if I can do that. So let's say the ratio we are having is x is to y is to z, which is in the simplest form, and they are all integers. Fine. So the condition is that two terms must add to the third term, then it will be a right angled triangle. Let's say we are having that x plus y is equal to z. Let's say x plus y equals to z. Okay, we are having this. Now we know that so let's say the ratio of the angles is coming like this: angle A is to angle B is to angle C is x is to y is to z, and these ratio is in the simplest form, and all the terms are integers, and we are having x plus y equals to z. Now see that angle C, what is angle C? Angle C will be z by x plus y plus z divided by multiplied by 180 degree. What is this? Z by x plus y is z, so z plus z multiplied by 180 degree. So this is z by 2z multiplied by 180 degree. This is half into 180 degree. This is 90 degree. So in this scenario, if we are having x plus y equals to z, the angle C will be 90 degree. It could also be the fact that x equals to y plus z, or it could be y equals to x plus z. In whatever combination we are having, the addition of two terms is equal to third term in the ratio, then the triangle is a right angled triangle. Okay. Point number 15 is saying that if it is given that in a triangle, the relation between the angles are given like this, that P times angle A is equal to Q times angle B is equal to R times angle C, where P, Q, R are some numbers, are some non-zero numbers, and definitely not non-zero, non-negative. They are positive numbers. P, Q, R are positive numbers. It could be fraction. They could be integers. So if we are given this kind of relation, that P times A is equal to Q times B is equal to R times C, then how do we find the angles, individual angles A, B and C? So the formula is angle A will be 180 degree divided by PM, and what an angle B is 180 degree by QM, and angle C is 180 degree by RM. PQR, we know it is given in the relation, that is P times A equals to Q times B equals to R times C. We are having PQR from that relation. Now what is M? M is equal to 1 by P plus 1 by Q plus 1 by R. So this is the relation, this is the formula, quick shortcut formula that you can, you can remember. If you can remember, it is well, but it is not really necessary to remember everything, because it is a more wise decision to understand the fundamentals and solve any problem from the very basic or fundamentals. I'm just as a reference giving you these shortcut formulas. If you can remember them, it is fine. So we are having angle A equals to 180 degree by PM, B 180 degree by QM, and C 180 degree by RM. Now if you want to see, if you want to quickly check how this is so, let me quickly discuss this. So we are having P times A is equal to Q times B is equal to R times C. Let's say if I call this as X or whatever, some number K, A, B, C, whatever, a small letter, an unknown. So usually we consider the letters X and Y and Z as unknown variables in mathematical, in algebra. Now, so let's say since it is given that P times A is equal to Q times B is equal to R times C, let all these be equal to X. Now this will imply P times A is equal to X. I will get angle A equals to X by P. Similarly, I will get angle B equals to X by Q, and I will get angle C equals to X by R. Now we know that angle A plus angle B plus angle C should be equal to 180 degree from angle sum property. Now this implies if you substitute the values of angle A, B and C in terms of X, we get X by P plus X by Q plus X by R, this equal to 180 degree. Now if I take X common, I get 1 by P plus 1 by Q plus 1 by R equals 180 degree, and this expression 1 by P plus 1 by Q plus 1 by R, I am assuming that to be equal to M. If I consider this expression 1 by P plus 1 by Q, this will be known, P, Q are known. So we get XM equals to 180 degree. This implies X is coming out to be 180 degree divided by M. So from here we can see, we can find angle A. What is angle A? Angle A is X by P, X by B, X by P. So we have 180 degree by PM. Similarly, angle B, what is angle B? Angle B is X by Q, X by Q. So we have X is 180 degree by M, so Q M, and similarly angle C, we have X by R, this is equal to 180 degree by R N. So this is how we got this formula. So if you remember this shortcut formula, it is fine. You can directly, you can save some time in solving this kind of problems. Otherwise, you can solve this problem from the basics fundamentals by considering all these equality to be equals to x, and then proceeding as I just discussed. Okay, I don't think there are any other points. Okay, that was all regarding the key concepts and points that, in my opinion, in my knowledge, and in my understanding, this will cover all the required concepts and formulas and theorems that you can use, and you must be very much aware of this to solve most variety of problems. And I will attach, so there are some sample problems I prepared. I will attach the PDF. I will give the link to the PDF of that paper in the description below. You can check that out. So I hope this video was beneficial. If it is so, then please like it, share it with your friends, and also once again, please support me by subscribing to my channel, and please do not forget to press the bell icon so that you will be notified by my future videos. The next topic C on the concepts to remember for chapter properties of triangles will be triangle inequality and Pythagoras theorem. So that will end all the topics of chapter properties of triangles. So please stay tuned for the next video on topic C on the triangle inequality and Pythagoras theorem. And until then, take care and bye.